This is Thursday, October 13th. Good morning again. This is a pre-recorded lesson, and we're going to be looking at lesson 3. This is my last day at OFSA, and I'll be back tomorrow to answer any of your questions. But please watch this recording so that we keep on track. Hi, everybody. All right, so let's go and check out this lesson. So we are going to be looking at factoring. So please press pause at any point. Make sure you have lesson 3 in front of you and something to write with. We're going to be factoring trinomials of the form x squared plus bx plus c. So we have no a value in front. Okay. All right. So some things that we've looked at in terms of expanding are that distributive property. So that rainbow, where the 2x gets multiplied by both of them. So this is where we get 2x times x is 2x squared, and 2x times negative 5 is negative 10x. We also looked at FOIL, first, outside, inside, last. Right? We did that on day 1, or lesson 1. So x squared, x times x is x squared, x times 4 is 4x, negative 3 times x is negative 3x, and negative 3 times 4 is negative 12. Put those middle two together and you get your trinomial. Today we're going to be looking at perfect square binomials and difference of squares. So we're going to be looking at both of these. All right, but before we do that, let's go look at what a factor is. So factor, the numbers that are multiplied together to form a product. All right, so 2 times 3 is equal to 6. The factors are 2 and 3. Those are the two things being multiplied together. And their product, the answer is 6. What two things are being multiplied here? They're the x plus 1 and the x plus 2. Those are the two factors, x plus 1 and x plus 2 are being multiplied. There's a multiplication sign here. And their product, their final answer is x squared plus 3x plus 2. So to factor something is to do the opposite of expanding. So the opposite, we're not expanding anymore. We're moving from this to its factors. Opposite of expanding. All right. So to factor a binomial of the form x squared plus bx plus c, we need to find two integers whose product. We need to find these two integers. So find two integers whose product, that means to multiply, is equal to, well, we want it to be equal to, is we want it to be equal to c. So two numbers that multiply to give you c, and whose sum, or it could be difference, so whose sum, so to add or subtract, is equal to b. That's what we're looking for, is equal to b. So two numbers that multiply to give you c and add or subtract to give you b. You must pay close attention to the sign of the terms. Right, and in order to do this, we use something called man method. So we're going to find two numbers that multiply to give you the last number, which is c. So we're multiplying to get c, and we are adding or subtracting to get b. And once we get those two numbers, those are our numbers, and we're going to put them in x, and then we'll put a plus that number, and then we'll have an x plus whatever that number is. And that's it. That's our final answer. This is where our numbers are going to go. Let's just like leave them like blank right now. Okay, so let's go try this out. All right, so for factoring trinomials, we're trying to get two numbers that multiply to give us the last one. So we're going to write that here, so 36. So now what we do is we go and look at the numbers that multiply to give us 36. Well, 36 is 1 times 36. And 1 and 36, if we add those together, that's our sum. If we add those together, we get 37. Is that a, add and give you the middle number, is that 15? We're getting 15 here? No. So it's not going to be 1 and 36 are not going to be the two numbers. Okay, so again, we're looking for two numbers that multiply to give us 36 and add or subtract to give us 15. 1 and 36 do not give us 15. What about 2 and what times what is 36 and it's a 2? 2 times 18. What about 2 and 18? Can that give us 15? No, 2 and 18 gives us 20. So that doesn't work and that one doesn't work. So it's not going to be those. What about 3 and 12? Can 3 and 12, so 36 being divided into 3 and 12 when they're multiplied, can that give us 15 if we were to add those together? Yeah, that gives us 15 because 3 plus 12 is 15 and 3 times 12 is 36. So our numbers are 3 and 12. So that means our final answer is going to be x plus 3 and x plus 12. We got it. Those are our two numbers, 3 and 12. So we write it x plus 3 and x plus 12. Right, so we don't have to do these other ones. But you can go and check and see like 4 times 9. 4 and 9 is 13. That's not 15. What about 6 and 6? That's 12. That's not 15. So the only one that works is 3 and 12. All right, this one, two numbers that multiply. So our m is going to be the last one. Not just 18, but negative 18. So we want two numbers that multiply to give us 18, and those same numbers add or subtract to give us 7. All right. So that is our 7. Our 7 is the middle term, so it's always the last term is m, middle one is a, and we're trying to find two numbers. Okay, so for the product of 18, 18 is 1 and 18. Can that give us, when we add those together, we get 19. So that's not going to work. 1 and 18 doesn't work. What about negative 1 and 18? Negative 1 and 18 is 17. That's still not 7. That's not working. 2 and 9. Can 2 and 9 give us negative 18? That doesn't even give us negative 18. Well, that gives us 11. That doesn't work. What about negative 2 and 9? Can that give us 7? Absolutely, that works. Because negative 2 plus 9. So negative 2 plus 9 is 7. And negative 2 times 9 is 18. And then what's our final answer? Final answer is x minus 2 and x plus 9. Those are our two numbers. So a lot of the time you guys get the numbers, but you forget to write down the final answer. So make sure you're writing the x minus 2 and x plus 9. So step 1. Is to, well, first of all, you need to write man. Write M-A-N, where M stands for your last term, the term that gets multiplied. A stands for your middle term, the numbers being added, and N is your numbers. Step 2 is to write the numbers beside M-A-N. Step 3 is to find your numbers. And step 4, you need to write it in terms of x plus your number and x plus whatever number you have found. Okay, press pause to write that down. All right, perfect square trinomial we have here. All right, so if the first term is a perfect square, and the last term is a perfect square, if the first term is perfect square and the last term is also perfect, and then they have square already there for you, then you might have a perfect square trinomial. That means if your first number is like a 4 and your last number is a 16, like 4 is 2 times 2 and 16 is 4 times 4. It could potentially be a perfect square. Let's think of all the numbers that are perfect squares. So we got 4, 3 times 3, 9, 6, 10, 4 times 4, 16, 25. These are the numbers we're looking for. 36, 49, 64, 81, and you can keep on going. Right? Those are the numbers we're looking for. So your first term and your last term are perfect squares. You might have a perfect square trinomial. So let's go ahead and do man. So what's the number going beside m? Yeah, it's 25. A is -10. Thinking of two numbers that multiple, and you don't have to use this if you don't want to, the product table. If you like it, go for it. If not, that's okay. So two numbers that give you, multiply to give you 25. So 25 is 1 and 25, so 1 and 25, well that's 26, that doesn't work. What about 5 and 5? Can 5 and 5 give you 10? Yes, but how can it give you -10? Well, just -5 and -5, that's -10, so those are the numbers we're looking for, is -5 and -5. So we get x minus 5 and x minus 5. Well, look at, they're identical. That means we can write it x minus 5 all squared. So this is an example of a perfect square trinomial. And the reason is because the first term is a 1, and that is a perfect square. And the last time is a 25, which is also a perfect square. If we square root 25, we get 5. If we square root 1, we get 1. Forgot to add a 1 up here. And the middle term, ignoring the sign, is, it's always 2 times the first and last number. So that means the square root of 1 is 1. The square root of 25 is 5. Square root of, so if we have x squared minus 10x plus 25, the square root of 1 is 1. The square root of 25 is 5. And if we do 2 times 5 times 1, if we multiply these by 2, we get the middle number. We get 10. So to determine the sign of the factors, if the middle term is a positive, like here the middle term is negative, we just get a negative right here. If it's positive, we get a positive. So if the middle terms are positive, then the factors are positive. But if the middle term, like what we just had, is negative, then the factors are also negative. Right, for factoring a difference of squares, we're going to have something like this. So then this is when your first term is a perfect square. And the last term is also a perfect square. But we only have 2 terms. We don't have 3 terms like before. So we only have 2 terms. So we take the square root of the first to get x, and the square root of the last to get, so this gives us x, this gives us 5, and we write it x plus 5 and x minus 5. It's like an evil and good twin. Which one's evil? Yeah, the negative one. It's like an evil and good twin. They're both identical, but one's plus and one's minus. Same with this one. So again, there's just 2 terms. There's a 1 in front of there. So square root of 1x is just x. The square root of 81 is 9. And we get our evil and good twin. X plus 9 and x minus 9. It doesn't matter which one comes first. We can see that these are difference of squares. Why is it a difference? Because we have minuses in here. They're both squares because they're square rootable. The square root of x squared, the square root of x squared is just x, because the square and the square root reduce each other. So the 3 types of factorings that we've seen before is just our man method. So man, we've looked at perfect square trinomial, or perfect, just write down perfect square. And the last one is a difference of squares. Alright, so this next part here we're actually going to do later, so we'll do this later together. Same with this over here. What I'd like you to do now is go turn over to the homework. So again, press pause at any time. Let's go check this out. I'm actually going to stop recording and make a second part, okay? So we'll do the second part. Good morning, everybody. This is Wednesday, October 12th.